Aloha, Rich Alverson. This is ITS128, and this is the first video of this semester, August 26th, 2025. So let me share my screen. Share number one. All right. So log into Lamaku and find your course, under fall 2025, 2025. Click on it, and let's see. I guess this might be the first. So is this like the first semester of your first year at KCC? And you guys, is this like the first year? This is the first year for you, huh? Okay, great. Um, okay, so um, the important part. All right, I'm going to go through. Oh, let me just see what the students see. So this is supposed to show me what you see. Okay, I guess this might be close to what you see. I don't know how to get rid of this. We aren't going to have any video assignments in here. But okay, so the important okay, the content tab is probably the most important tab. And if you click on the content tab for the first time, it should come up with this course overview, which is the syllabus. By the way, this course overview link is the same as the syllabus link. I posted it up there twice. Um, and so this course is this course is both the online asynchronous version of the course and the face-to-face session, face-to-face slash online session. And so this is when we're meeting right now. This day today is the required day of the online or of the face-to-face class. And after this, we're going to have face-to-face classes, um, sort of like when requested. So if and this is a good time if you want to meet with the instructor. This time in this classroom is good because because it's reserved. This time period in this classroom is reserved every day this semester. Um, you can always when I'm doing synchronous sessions, like this is a synchronous session, you can whether you're here or not, I will be recording it, and you will be able to click on this. This is the meeting ID, the Zoom meeting ID for this class. There's going to be a playlist, and this is going to be the first video of the playlist. So after this video is done, I'm gonna upload it. I'm going to upload it to YouTube and start this playlist called ITS128 Fall 2025 Halverson. Probably say Halverson after that. And then you'll be able to watch all the videos. I'm going to make lots of videos for this class, and they're all going to go on the YouTube playlist. Some videos I might actually do here if folks want to meet. Like if you want to have a session where we're working on the lab or something. But as you'll see from the textbook really is designed to be it's interactive. It's sort of work at your own pace, and it's really pretty complete. And it's not going to require a lot of lecturing from me. What I'm going to do mostly in the videos is to show you how to do selected problems. I'll just go through and I'll do some of the challenges, and I'll do some of the labs, and on some of them I'll tell you how to get started. Other ones I'll do them for you. And so the idea is with programming, you know, it's not very hard to learn how programming works. After that, it takes practice because you just practice and practice, and then it becomes real easy, and you it becomes effortless pretty much. All right, so the only class, let's see, I actually English, I guess you don't really need any, I guess there are no prerequisites. Even if you haven't had ICS 101, I mean, even if you haven't had that, this course should not be very hard because we start pretty basic. This is the schedule or the calendar, and you see we're doing one chapter a week, and so the textbook is configurable. So I've partitioned it all up so it's one chapter per week, and I've tried to spread it out pretty much. There are due dates here, but these due dates are recommended due dates. They're due dates for pacing. You can hand in stuff after the due date, as with all my classes that are all auto graded. All the assessments are auto graded. That's why I can do this. So, you know, my schedule is your schedule, and uh, it only takes me. In fact, with La Lima, it took me about 4 minutes to download the grades from the textbook and upload the grades to La Lima. But on Lamaku, it's even easier because there's a certain step I don't have to do. So I'm just able to download the grades from Zybooks and then upload them to Lamaku, and that's it. So that means okay, and so I'm going to do grades maybe once a week, um, maybe a little after the due date. And when I do them, I'll go all the way back to the beginning. So, for example, if on October 14th, on October 14th, um, I'm gonna upload all of the grades for all the way back to here. Okay, I'm not gonna upload grades down here early because if I upload grades here early and you aren't finished yet, then it'll show that you're only partially finished and it'll only give you partial credit, and then you'll wonder why am I only getting partial credit and all this, and well, like, it's because you haven't finished it yet. So I avoid all that. Um, so I upload grades all the way from the beginning. So that means if on if on October 5th you finish this, and this because you were busy and you finally got this done, um, when I upload the grades for this week, I'll go all the way back, so then no one will be the wiser. By the way, for that reason, I don't give extra credit because extra credit is to make up for work that you missed. And for me, I would way rather you just go back and do the work that you missed. Okay, that's really what I would like everybody to do. And there's going to be a few of you that do this, that you do all the assessments. Actually, I don't think you have to do. Okay. Oh, yeah. Okay. So you do all the participation activities, you do all the challenge activities, and you do 30 labs. And you can submit as many times as you want. So that means some of you are going to submit, and then you're going to get all the points, and you get all the points for all these, and you'll get, 100% all the points. At Manoa, you would get an A plus for that. Not at uh, not at the community colleges. We don't give pluses and minuses. But anyway, so so all it takes is persistence. And then after you're all done, and if you're having problems, if you're stuck, just email me and I'll unstuck you. Okay. And so the idea with this class, this is ITS 128. It's the first programming class of this, so it's presumably possibly the first programming class you've ever taken. So in this class, you should learn how to program. After it's all over, you might find that it's easy, or you might find it's kind of hard, or you might find it's easy but you don't like it. All that. I don't want your finding it hard to like and make it so you end up with a bad grade, and then you got a bad grade on your transcript and you end up switching majors, but you got this bad grade back there. Okay, so it's pretty easy to get an A from me, and then you decide yourself if you want to go on and do more programming. Now, there's lots of people that go through programming and their intention is never to be a programmer, but they know how to talk programming. They write programs. They understand it. They can communicate very well with programmers, and they end up getting a job where where they interface with program like a systems analyst. You interface with programmers because you're designing a system. You aren't going to code the system, but you're going to explain to the people that code the system, you know, how the features work and how they have to work. And you're able to speak the language of more than one group of people that that has to get a job done. I remember I started out in electrical engineering and I worked at Lockheed Martin in Eagan, Minnesota for a while, and we had representatives from the chip companies. The representatives from the chip companies would come, and so we were building electronic stuff, and we have to buy chips, and they knew the newest chips and everything, and I talked to those guys. They all had bachelor's degrees in electrical engineering. They were all engineers, but they didn't like designing. But they understood all the stuff. They understood all about the components and the parts. And if you had any questions on any of the parts, like the load, the current, all this and that, they knew all the answers. They could even help you design stuff, but they just didn't want to design for their jobs, and they're probably made more than the engineers. And um, so, and I there there may be some of you uh, taking this class. And so you end up not being a coder, but you end up using your understanding of programming and your programming skills for your job. All right, so this is the breakdown of the grades, just like all classes at the community colleges, pretty much. Um, so now I'm pretty easy regarding handing stuff in, quote, late. Okay, personally, um, I'm not here to teach you time management. But lots of other instructors at the community college are also here to teach you time management. So pay attention to handing stuff in on time and oftentimes they have schedules, their own schedules, especially um, if there's stuff that they have to grade. If you're handing in stuff that they have to grade, then you're working with their schedule and they have to get stuff done. And uh, one thing about um, when you have to manually grade assignments, you would really like to grade them all at the same time because if you're grading some of them sometime and then you grade some more of them, 2 months later, you don't remember how you assign grades. You don't remember, who you grade or what you gave points for and so on, or it's difficult, so it's not consistent. So anyway, so keep that in mind. And if try hard to finish everything by the end of the semester, the last day of the semester sort of is December. It's like around okay, the 12th. This 12th is the last day of class. Okay, this is the last day of class. Finals week is from the 15th to the 19th. And so finals, okay, so then and then so uh the weekend after finals is December 20th and 21st. So I want everything in by December 21st, okay? So I will accept everything without penalty or anything without penalty up to December 21st. December 21st, I have to turn in my grades. And they're stricter here at KCC when you have to have your grades in by 8 in the morning uh Tuesday. So that's why I I want them early. What I want to do is at the end of the day, Sunday, I'm going to tell you what your grade is. And then if you're close to the next grade, then I'll give you another day. And then you go in there and you do some more work and I'll bump you up to the next grade. All right. So that's the syllabus pretty much. Let's get into the textbook. Let's see. All right. So this is the textbook. It costs $89. It costs $89 and You have to register by, you have to sign up, you have to buy the textbook by December 8th. And every year there's somebody who emails me on the 9th and says, "Oh, I'm sorry, Dr. Howard, and I forgot to buy my textbook." And so then but I have to contact the publisher and they'll open it back up. Um, it'll stay open until January 7th. What that means is that, you can download anything. You can download all this stuff. So if you want to download it and have a paper copy of the textbook, they give you a bunch of time afterwards. Now, if I happen to give you, if you need an incomplete and I give you an incomplete, um, then they will, on a case-by-case basis, extend this up to the time that you have to complete the incomplete. So you don't have to buy the textbook again. So some people think that if they get an incomplete, they have to buy the textbook again. No, don't have to do that. All right, so I'm going to go through here and go through probably chapter 1. Let's see if you click on reporting, then you can see how far you've gotten. Now this here is how far the whole class has gotten. So I can see some of you have already gone in and started doing some of the participation activities here. Very good. Some of you have done some challenges. That's good. And no labs yet. All right. I haven't, it doesn't look like I've finished okay. I might rearrange some of this stuff. Okay. The other thing I'm going to do is I'm going to hide all this stuff down here. This stuff should not even be here. Okay. Um, the chapters of this class are chapters 1 through 16. Okay. The rest of these are not anything. In fact, I'm going to do that right now. So up to 16. This. Wait a second. Okay. This, 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 and this. Why isn't this? Oh. Or wonder why it looks like that. Anyway, it's unused. Move to unused. Did I really? What did I just do? I see what I just did. Sorry for doing this right now. Well, never mind. I'll do it later. Okay, so I'll do this later. Save without exit without saving. Okay, so let's just get started with chapter 1. Okay, so this textbook. Okay, so I've taught with this textbook, and this summer, in fact, I taught a class, and I didn't lecture like hardly at all. Okay, I just I showed my videos consisted of showing the students where to look in the sections to find what you needed to do the labs. Okay, and I didn't do any challenge activities. And for each chapter, I explained, what it was about, what you're going to learn. But then everything else is the students just went through and clicked through the participation activities, got through the challenge activities. A lot of the labs I kind of showed them. My lectures were on some labs. I showed them how to do them completely. Other labs I showed them step by step how to do it, but I didn't actually type in the code. And more than half the students in that class got all the points. Got all the points in the textbook. And that just told me it's like if I would have lectured, it's like they probably wouldn't have because I might have confused them. So now I'm going to do more than that because that was a higher level class. So I am going to lecture and I'm going to point to other videos that other instructors have made for this class, and they're very clear. And I'm going to do step-by-step things, more in this class because this is an introductory class. But really, this textbook is designed where you can like learn it all on your own. Okay. So I just want to let you know that. And if I'm explaining something and it sounds confusing, then what? Then just try turning the video off and reading the section on your own and going through the participation activities without hearing my voice. And it's a good way to to pick up what's going on. Okay, so we start out. Well, you can watch this. It's talks about the interactive activities and research-backed approaches and all that kind of stuff. Um, here it talks about just basically what a program is, and a lot of you know all this already. It's these step-by-step things. Here we and so you want to click through these because you want to get the points. Even if you know this stuff, you want to get the points. So I'm going to do it on double speed, and you click through this and it says a basic computer programs instructions. It's like get the input, click next, get the input for Y. Next, it executes this statement. It takes X, adds Y to it, and stores the result in Z. And then the last line of the program is it prints out Z. See, and so I got all so now I got the points for this activity. And then participation activities. How many instructions does the program have? Well, I don't. Well, just with these, you can just click this twice and it tells you the answer. Well, you don't want to do that, but just know that you should get all the points. You should get all the participation activity points because even if you're really tired or you're half awake and you just click through and you aren't getting any of them, you can still just get all the points. Maybe you won't absorb that much. But even just doing this, you want to know four. What do you mean four? Oh, 1, 2, 3, 4. Oh, that must be what. Oh, an instruction is one line. Okay, and so you have to put the four in there, and then you click the check, and then see you get the check there. If you put the wrong answer, it's gonna say no. It's this. Look, there's two of these, one of these, and then you fix it. But I already got the point. I already got the check, so it doesn't matter if I go back and later check it. And then this is suppose a new instruction were inserted as follows. Let's see if after this statement, Z is equal to 7, and then you were to add 1 to Z, that would make Z 8. And then you do the put Z output. What would the last instruction what would the last instruction output to the screen? Well, it would output 8 because now it equals 8. See, so it explains that. And then here, given this instruction or statement, this is really they say instruction, but later on these will be called statements. This is an assignment statement, and this is an expression on the right side. You evaluate that expression and you store the result into the single variable that's going to be on the left. And so if X is 10 and Y is 20, then Z is going to be 30 because 10 plus 20 is 30. So Z is assigned 30. So you put 30 here and you see that that's what the answer is. And so since I did all these, now I got the check up here. And so I got all these participation activities and all these. Great. A program is like a recipe. Yes. That's probably why this department is in the same department as culinary. Both dealing with recipes. It really is like a recipe. And that's why I say that there are very few people that just don't have it to be able to program. There are people that don't have it to have it that don't have it. But if you can write down the instructions on how to make a piece of toast or if you can write down step by step instructions to do something, anything, drive to Safeway or then and um and the thing is, you might write the instructions and then you go along and you realize you forgot something. Well, then just put it in and eventually you can develop perfect instructions to drive from your house to Safeway. And that's exactly what programming is. With programming, you start out with some instructions and then you try it, you run it to see if it works. And what's great about programming is if you type in a wrong program and you run a bad program, it's not going to ruin anything. It's not going to break anything. It's not the same as engineering where I used this analogy yesterday where if you're if you're designing a circuit and you put the chip in upside down, they they didn't design chips so if you put them in upside down, you know, that they don't blow out. The power pins on a chip are such that if you plug it in upside down, you're going to burn out the chip. So anyway, but chips are cheap anyway. Uh, and so these are baking chocolate chip cookies. I guess you can't put chocolate chips upside down. Anyway, so here, this is another kind of activity you have here, and it's kind of interesting because you can. This is this is executing where you keep on doing something to M. Okay, so this this is a programming statement here. You take M, you take the right side of this, you take the right side of what's on the right side of the equal sign, you evaluate that expression, and then you store the result in the single variable that's on the left. And so we see M equals M times 2. Well, what this really means is first you take M, you multiply it by 2, and then you store that new value back into M. And here we take M equals M times M. So you take M, you multiply it by itself, and then you store that value back into M. And here you take M, you add 15, and you store that back in M. And so here there's this program, the way it is, you see that M, in the end, M is 115. And so this is a little game here, I guess. Do these move? Yeah, it's a little game. You try to you can rearrange these to make M as big as you can, and what you want to do is you want to get M big as soon as you can. So let's see it. If you put this, what happens if you put this up here? Okay, this makes it 25. This makes it 50, and this makes it only 65. I guess you can see. Let's try putting this up here. $2,400, 800. Wow. I wonder if you can get it bigger than 1,000. What happens if you put this here? Okay, that must be as the size you can get it. All right. Anyway, enough of that. And so, go through and do these exercises, base height. All right. Um, so um, so this kind of explains the thinking. It's called computational thinking, and it's different than mathematical. Yeah, it's different than mathematical thinking, where with mathematical thinking is more like the expression, coming up with the expression itself, coming up with the equation, the formula. All of the famous, formulas that the scientists, in the 1800s and 1900s came up with. Um, and uh, those were single expressions like E equals mc squared, or force equals mass times acceleration, or Ohm's law is voltage times current equals power, and so, but That's not computational thinking. Computational thinking is coming up with an algorithm, a sequence of steps to do something. So, so computer science and computer programming is mostly computational thinking. Uh, uh, Databases, SQL, that's not really computational. That's really more mathematical. When with databases, you want to come up with a single SQL statement. And so, there are people that can, they just come up with these nice, great big SQL statements, and it's all just one statement, and the statement executes, and then that's the result. It's not first you do this, then you do this, then you do this, and then you loop for a while, then you do this. That's um, the computational thinking is the kind of thinking that that you need to be comfortable with to be a programmer. This here is a program for writing. Uh, this is pen. You can run it pen down. Forward 100, left 120, forward 100. These this means degrees. Turn this number of degrees, then go 100. Units, and then go left 120 degrees, and then go forward 100 units. So that's writing a triangle. You can change these around, and so that's just another example of computational thinking, creating algorithms to draw shapes using turtle graphics. We aren't gonna learn turtle graphics in this class, I'm pretty sure. I don't think we do. No. All right. All right, so you can take a look at that and go through that. Let's okay, so here I guess here we introduces you to Python statements. Um, so uh, skip right now. So you should probably read that. Okay, there's a Python interpreter. Uh, there's a Python interpreter, and then there's do we? Let me see. Is there a built-in? Okay, if you go to the last section of this chapter, um, this you can actually write a program here. Let's see, can you? No, you can't. Okay, you got to do it up here. It's one print. All right. You can write little programs in here. And so, later on, you may want to try things, like, even if you have like some of these challenge activities, like, here's a challenge activity, like here. Well, which operator is evaluated first? It's not a good one. Okay. Type the program's output. Okay. So it's in this case, it's okay. So let's just start this up. Okay, the first one. Type the program's output. Well, what you can do is you can copy this. Oh no, just copy this whole thing. I shouldn't be telling you this. Copy this whole thing. Go to here. I'm going to open this up in another window. Go here, paste it. Oops. Paste it here. So there's the program. Run the program. And it's 21. So go back here and type 21. Whoa. Uh-oh. Oh. Okay. what I didn't do is it's 21 enter. See, so it stopped on the next line. Every time you print something, it's gonna also print a carriage return. So it's gonna print Y and then a carriage return. So I didn't get it right because I didn't put the carriage return. I should have done this. Carriage return. Oh, but now it's 17 plus 4. Yeah, it's 21. Check. Okay, so now I got that one right. See, so make sure you put that carriage return. Whenever you see just a print like that, it's going to have a carriage return at the end. You have to do something special so it does not put the carriage return at the end. It's this. End equals nothing. Okay. See, now it just prints and it doesn't print the carriage return. Take that out and you run it and it does the carriage return. Anyway, that's programming. All right, let's go back and look some more at chapter 1 here. Good. Okay, so I want to show you some, let's see. Oh, let's just kind of buzz through this because I want to get to some challenge activities. Okay, so the Python interpreter, see, I started this because there is no, see, is there a Python here? Let me just see. CMD, Python. Ah, there's a Python here. Okay, you can install Python, okay, on your computer at home. All you do is you go to python.org, I think, and click download, whatever, and you install it. You can always, and if you don't know how to install it, just search YouTube, you know. Uh, Online is one of the fastest and easiest ways. How to install Python. And it's very short, very easy. And so when you have a Python interpreter, then you can actually do these things that they suggest here, where let me see if I can do this. Put this. So you can go wage equals 20. Hours equals 40. Weeks equals 52. Salary equals wage times, let's see, so you're learning, that's the symbol for times, it's an asterisk, times hours, you can put spaces or not, times weeks. Okay, so now we have a value for salary in there. So now we have four variables that all have values. Wage has a value of 20, hours has a value of 40, weeks is a value of 52, and salary has a value of whatever wage times hours times weeks is. Well, let's print out what that is. Salary, let's print out salary, and it's 41,600. See, that's what it is here. And then, so this goes through, and so you can actually go through this and do this. Hours equals 35. And then we have to actually say, this salary is still the same. It's still that. Okay, even though you change this value, that doesn't change salary. You actually have to execute that statement again. Salary equals wage times hours times weeks. Okay, now when you print salary, now it's the new value. All right, so it's handy to install Python and to do these exercises at the command line, or you can, let's see, exit. That's how you get out of there. Or you can actually, I guess for now, if you want to look at running programs, you can go back and use, this thing. And then later on, I'll talk more about. I'll show you how you can um, write programs using an editor like Notepad. Um, yeah, I'll show you that later. Let's go back and let's quit getting distracted here. Okay, so we were looking at chapter. Okay, so how to use this tool. Okay, a program that executes computer code is a program that executes computer code was interpreter, I guess. Text that represents a computer program is code, I guess. Informs the programmer that the interpreter is ready to accept command. So that would be a prompt and then a row of text, whatever. Okay. So this is just some terminology. Statement is the program instruction. You remember earlier I said these are called statements. Expression is what's on the right side of that equal sign. This is an expression. An expression evaluates to some value. And then that value, you got to do something with that value. And a statement will execute that expression and then put that value into whatever the variable is on the left side. Print statement and comments, you can put this, you can start a line. If you start a line with a hashtag, then that's just a comment. So that's not part of the program. That's a note to yourself of what that is. So you might have something like, let's say you have a program like this. Let's copy this and put it. I'm going to pop this out again in another tab. So if you put that program here, oh, in fact, that was a comment. This is a comment, see, because it starts with a hashtag. But anyway, so you can put that program here and you can run it and you get, oops, there's going to be an error. You're going to see what an error looks like. See? Error, line 10, that's this line. This print statement, there's a beginning parentheses and there's a syntax error. The beginning parentheses was never closed. Okay, see, I forgot to copy the ending parentheses. So I do that and now it'll work. So now it works, but you might want to say, recompute with new hours or something, just a comment. And it doesn't do anything. It's a note to yourself. So what's the purpose of variables? To store values for later use. The code 20 times 40 is an expression. Yes, that's an expression. How are most Python programs developed? By writing code into an interactive interpreter or by writing code into files. It's this one. Okay, it's so let's see. CD desktop. Does this work? Okay. Okay, so if I write a program, let's Notepad. Here, Notepad. Here's Notepad. And is that program still in there? Yeah, that program is in there. Um, so this is a program. I can save this, save as. I want to go to the desktop, and I'm going to call this my program.py. Okay, myprogram.py. Is it, it is right. Oh, wait a minute. Oh, here it is. myprogram.py. There it is. So now I'm at the desktop and I do a dir, I should see. There it is, myprogram.py. So I can do Python myprogram.py and it runs it, and there it is, my salary. See, this is the output of it. So this is how most people, run Python programs. They type them into a file and then they run the program this way by typing Python and the name of the program, and then it executes the program. So that's why this is the answer. By writing code into files. It's not this way. It's not this way. All right, my first program. Oh, look, my first program. What do you know? There it is. There it is. Okay. So, oh, good. There's a challenge activity in this section. Okay, so here we're learning about basic input and output. So we kind of know about output, this print statements. So, you want to click through this, see what that is. Prints that, and it prints that. And I got the check mark. So select the line that will print this. So print this. Well, it's not this. It's not the first one because it's got to have quotes. It's not the second one because the quotes have to match. These aren't matching. It's this one. They match. Okay. Okay, so we're supposed to figure out which statement here is going to print this. Well, it's not the first one. It's not the second one because you have to have parentheses around the print statement. In this language, you have to have parentheses around the print statement. In Python 2, I don't think you do, but anyway, so it's this one. Okay. How do you print this thing there? Well, it's going to be, none of these will work. This one doesn't work because there's a quote there, but there has to be a quote on the other side here. This one doesn't work because it's got to have the word print in front of it. This one doesn't work because that's syntax error. So it's going to be this one. Write a line of code that prints this. So print, quote, hello. Okay, is that right? Yeah. See, it says it's correct, even though in this example it's got a double quote there and I did a single quote. So this one would be print, email sent. There we go. All right, so you can do that. How do you print this? Well, first you're going to print. Oh, that's weird. Okay, first you're going to print all. Am I supposed to put it over here? I'm supposed to put it over here. First I print that thing. Then I'm going to print one of these. And then I'll print one of these. And then I'm going to print one of these. And then I'm going to print one of these. There. Oh, that was a challenge. This was a challenge activity. Oh, okay, I got it. Is that it? Okay, so so we're learning more about the print statement. Okay, so you can print more than one thing at once, and you separate the things that you're going to print with a comma. So this is going to first print these words, and then it's going to put a space, and then it's going to print whatever that value is. So here we're printing your daily wage is $, and then space, and then the wage. So it prints this thing. Oops, just like that with the space after the dollar sign. There's a bunch of different kinds of ways to print. This is the easiest, cheapest way. Okay, so here, first we're printing a dollar sign, then I'm going to print a value for wage, then we're going to print per day is dollar sign, and then we're going to print a space, and then we're going to print a value for whatever that value is, and it's going to print a space, and then it's going to print these two words. And so that's why it looks like this. Looks like that. And oh, I guess you should click through this to see that it works. This course goes to 130, doesn't it? Okay, let's see, what else is a good thing to learn? Okay, as you can see, you should be able to go through all these pretty easily. Okay, let's do another challenge here. By default, the output ends with a new line. For each print in the activity, type the program's output and then press enter at the end of the output with a new line. So here it's just telling you to make sure you print that new line. Okay, so I guess we're going to play program executor. Okay, so start. We're supposed to type the program's output. Well, of course, we could cheat, go back to here, but I'm not going to do that. Let's just type it in. It's that easy. So easy. Okay, so this is a comment. See, there's a hashtag there. This is going to print Bob is nice. Period. Enter. Yeah, there we go. What's next? Print Joe and oops, Joe enter is enter. Happy period enter. There we go. What's next? Okay, I'm gonna make a mistake just so you can see what a mistake looks like and see how it handles it and see how it gives you another chance. Okay, person age is 24, and then there's a comment, and then it says each item in the output will be separated by a space. See, it's telling you, it's actually telling you. Well, I'm going to ignore that, and I'm going to type Bob is colon, and I'm going to put 24 without the space. But I'm going to still put the enter. And what does it say? Bung. Oh, look, it expected a space there, and I didn't put that in there. So try again. It's exactly the same one. Well, okay. All right. Okay, this time it's going to be Ann is space 24 space years old period enter. Oh, by the way, yours might be a little different just because there's more than one, there's for each one of these, there's several in there. And so, what pops up for me might be different than what pops up for you, but you'll just it should be the same though. I mean the thing you're learning should be the same. All right, you can go through all that. So I got all those points. I'm gonna do are we doing input yet? Here, okay, so here we're doing input. So this one first asks to enter the age of a dog in human years, and the prompt is this thing. So, and then it takes what you enter. Now, it's going to take a number, but really it's a character because when you type in something like 123, you're typing the character 1 followed by the character 2 followed by the character 3. Okay, so that's what it sees. It's not seeing 123. It's seeing character it's seeing three characters. So you have to wrap it in this int function, which takes what you input, which is three characters, and converts it into the number that those three characters represents. It turns it into the integer that those three numbers represents. Really, what this should really be something like, can I mess with this? I think I can. It really should be uh human years characters, I'm going to say, equals input, enter age of dog. Okay. So I'm going to say that, and then I'm going to say human years car. The integer of that is that. Okay, so we can still run this. And it asks for the age of the dog, and I'm going to say 70 or something. 70, and it's going to say, oh, I should have said 7. Okay, I'm going to run this again. 7, it's going to say it's going to be 49 years. Okay, so when I type in this 7, I'm not typing in the value 7. I'm typing in the character 7. And so this is actually, a character. And then we want to turn this into the integer that represents, because we're going to do some we're going to do some arithmetic on it. And so that's what this int function is. The one thing I don't like about this textbook is that right away in the first chapter, you have to understand what this is. Okay? What this is this is the prompt for an input, and you're going to take that input and you're going to perform this int operation on it to convert it from the characters, into the actual value. Anyway, more on that later. It's 1:31. I want to do real quick. I want to do one of these. Okay, some of these. Does this one give you the answer? I guess this one. Okay, so this is just an. Okay, so just so you know, if it starts with the word practice, then it actually tells you the answer. I think it tells you the model solution. I think you can look at this and see the answer. You can tell me if you can, because I'm looking at the instructor version of the book. But so that even helps you more. If it doesn't say practice, then it's not telling you. It doesn't tell you the answer, and those may be ones that I do. So if in fact, let's do this training one large program. Basically, what this does is this is telling you that you can write your program in steps and test it. You can submit it when you're only partially done, and you can see if you got the points for the step already. So here, if we do this, step 1 is to use a print statement to print this out. So let's do step 1. That's going to be, I can leave that there. Print. Oops, it's got to be lowercase. Print. Step 1 complete. Okay, so that's step 1. If we run this, it says step 1 complete, and so we should be able to submit that for grading and get 4. Got 4 points. Very good. And but we didn't do the rest of it yet. So the next part is to do use the print to print that out also. So I'm just going to copy this. I'm going to say print, print, paste. Okay. And so it should look like that. And if we submit that for grading, so now we got 7 out of 10. And the last one is print this. Now this is a really dumb programming example, but it's just showing you that when you are doing your labs down below, you can do this one step at a time just to see if you get it right as you're going along. If you're to type the whole program in and then you run it and it doesn't work right, you're not sure where the problem is. But if you just type in a little bit and run it, see that works, a little bit more, run it, see that works, then if you're doing that and you run it and it doesn't work, then you know it was just the last little step that you did. Okay, so that's all done, and we submit for grading. And we got all the points. So we got 10 points there. And so up here it shows 10. And so that I got all the points for this lab. Well, of course, this was a very, very simple lab. The ones, later on are more difficult. Uh, but I will, for a lot of these, I will be taking you through them step by step. All right. So I've pretty much covered everything, the different types of activities that you'll be doing, participation. You should be able to get all the points for challenges. You should try to do them on your own. If you really are stuck, I don't think you'll be stuck with any of them, because being stuck would probably means you don't know what they're asking. And for all of these challenge activities, I'll go through and I'll probably do like the first one so you can see what it's asking, and then the steps after that are just a little bit more complicated than that. So for those, you should be able to figure out. All right, it's 5 minutes past, right? 12:15 to 1. Okay, does anybody have any questions? All right. So look forward. I will be making videos probably like once a week at least. And if you have any questions, just email me. Texting me is the best way to get a hold of me. First time you text me, just tell me who you are, and then I will put you in my contacts. All right. So I will see you next time. Thanks for watching.